Hi dear Emco group, today I want to show the disassembly and assembly of my modification to the tool turret from Emco Compact 5. We use a Nema17 stepper drive, stepper motor. It's screwed to a self-made adapter. I found in the last days the CAD file of the Emco Compact 5 CNC, and yes, it's nice to have, but I measured all by myself and get very tight fittings. It need a little bit alignment, but it's easy. I use long M3 studs. I bought a 1 meter M3 thread at the building shop for 60 cents. Screw it to my adapter. My adapter uses the original mounting points of the original DC drive from Emco. So the motor is from Maxon, and I think the gear is also from Maxon. So I use the original threading points. You can see. I put it back. I mill all parts with my small CNC milling machine. Some processes you can see in my channel from YouTube. I use this mill. It's every day. Every day I need a part, I mill it with it. And it's my working horse. Screw it all back. The fitting is very tight. I must lose the other screws to get the last screw in. Original is M2.5 threading. For tightening, it's aligned by itself. The Nema use M3 long screws, but I drilled out. To mount it over the studs with this small long nuts. This long nuts from a super old PC. It's a PC from the 90s. It's a 38.6 Intel. I grab some parts from it and throw the rest in the garbage. And here is an Imperial thread into it. And I cut it out. I drill it out and cut M3 threads into it. This adapter has a zipper tight fitting. I don't want to extract the worm gear because I lost the alignment. And if I lost the alignment, it would be 15 minutes to align all together to show you the function. So here I use M2.5 group screws. Between these group screws sits a ball from a damaged bearing. The ball has a size of 2.2 millimeters. It's to use in 2 group screws, tightening it together and to fit into the slot of the worm gear shaft. Now I screw it in. Only hand tight. The reason why only hand tight is the stepper motors has a spring plate here and here, and if you tighten it too strong, you get the problem that you lost a little bit of movement what you need to rotate the stepper motor correctly, because it's China steppers, and it's not super precision. Only hand tight. Now I will check if the alignment is okay. I go to my CNC 5. Put it to the stepper drive. I use it as Z-axis. C-axis, not Z-axis. So, and to check it quick, we use G91 C20 with a feed rate of 400. That's the problem I talked about. It's too tight. Again. Now it has the alignment, and we can go check it again. It works. So we can go to a higher feed rate. Oh. It's a feed rate of 1500 millimeters per minute. I use quarter steps. This is the speed. I think it's okay to make a tool change. Now I show you the sensor side. This was not the best thing to show you all, because the alignment is not very precision, but it works. I done it very simply. This is the sensor side. I have here made a plate with M10 DIN thread. This part you can see in my channel. I cut it on the Emco Compact 5 CNC. Is to hold the cable on position. So if I screw it in, the cable don't move back and forth. Then I take off the housing. It's all built on my Nema17. I can quick show you. This is the housing. I must grind it on sandpaper that I get this finish. Here is the sensor. A built adapter from the original threads to hold the housing and hold the sensor. On the sensor here is the next cable holder. This part here. Take off the sensor. On this part, here is a curve. This curve, here is the opposite. It's only fit in one position. It's every time the same position. It's a H44 Hall IC from cheap China Arduino boards. Experimental boards. It has a resistor and a LED, and the LED shows me that I have the right position found, or shows me that the Hall IC works. I had the idea to make on the end a small hole herein and put or glue in acrylic glass and see the blinking of the LED without losing the two screws to which I mount which is used to mount to which I use to mount which I use to mount from the housing to my bucket. I don't know the right word. And here you can see the magnet. This magnet I use the north side. Normal, the IC, the whole IC works with the south side, south pole. But to make the circuit board so super small, I must rotate them. And the south side is on this side and the north side is on this side. So the IC is mirrored to get this small PCB. So now I put it back. With the whole IC and with the magnet, I identify the homing, the reference position for the turret. The idea was to use only one sensor, which is used to find the homing position. And from this position on, after you home your lathe, you are on tool 1. And if you want to make a change to another tool, you have your reference position. This was the idea. Yes. Now, yesterday I shortening this out. Now it's not good because I can show you all, but I will cut out the wires. And I show you the function. Let us go to my Nema17 site. This is my working hearse. It's a MF17 from Proxon, complete rebuild. I use GRBL advanced to adjust the backlash, and yes, you can see I make small PCBs and other things with it. You can see it on my YouTube channel. Check all. I must show the cable colors. I forget them. So brown is the signal. More I don't know. More I don't need to know for this test. Now I connect to my power source with 5 volts. And then I use the y-axis of my Nema17 controller. 17. So from now we have the area where I can, yes, where it's homed. You hear it's engaged, but we have this gap. And the idea now is to use the function of getting back and this is the home reference. That's all. You can see here is the lightning scene, and from this point I go 5, 4, the next engaged, again, and here you can see that's the problem with the cheap steppers from China. The gap get bigger. And the idea was to make it every time you do a tool change, make some steps back, and when you get the steps back, you delete the position to 0, and then the next tool is the next distance from 0 to the tool. So if we want to change from tool 1 to tool 6, we must rotate 300 degrees from this point on. and then go some steps back and delete the position, zero it, and then the next positive thing is we have the pole and we have the inertia of the worm gear. That was my idea.